It's recording. Just go back to that. Hi, I'm Matt. Welcome to Human Dimensions in Immersive Environments, Week 1. I'm assuming that you would have already listened to my introduction video, so I won't go through that again, things about assessments and overview of the unit. So if you haven't gone through that already, please have a look. Okay, what's next? Well, I'm recording this in a studio all by myself. I've got like my little light board here, and there's like a monitor over there, and my slides over here. But yeah, it's very low production because it's just a one-man production team. So I guess what I'm trying to ask and say is please forgive me. But we can just pretend that this is a face-to-face lecture. Unfortunately, we're not actually able to have class face-to-face just yet. We're a little bit, we're still a little bit iffy on all the virus stuff. So this is the best we can do. So I'm going to try and pretend that there's banter and all that stuff. But I'm not going to have all that special effects and music, things like that. I might have a few cuts in the edits, but I know we did that quite a lot in my introduction video, so I'm going to try and minimize this as much as possible. But yeah, so let's go straight to it. So week 1, modalities of interaction. Okay, so I'm just going to rub this out. So in the slides, if you're following along, we're in slide 1, Milgram et al. 1994. A reality-virtuality continuum. So I guess on one side we have reality, which is just the real world, and then on the other side we've got something that's completely virtual. So reality, virtual reality, and in between then I guess we have like things like mixed reality. And that's pretty simple to understand. But if we move on to the next slide, there's actually a lot of things. So in this particular slide, I won't be able to enumerate all the different things that fall into the different places within this continuum. But that's pretty much what we're dealing with. And I wouldn't expect anyone to be able to put every single thing into this diagram because there's just way too many. These are just like quick examples that I thought about off the top of my head. So let's not concentrate on this too much because we're going to get overloaded. But what I'd like to do is let's define what we mean by immersive experiences first, right? So what do we mean? So this isn't really a definition that's widely adopted just yet. Like there isn't like a one single authority that says this is what immersive experiences are. But I'm just kind of trying to pin down what we mean within this group by immersive experiences, immersive environments. So for this, let's say that it's not just a screen. But so it's not completely abstract. Let's mention a few examples, but let's not overload ourselves. So over in the VR side, very typical thing we would have. Oh, that's not. We'd have the Quest, for example, and I guess that's not really Oculus anymore. It's Meta. And this is one of the things about this particular field. It moves so quickly that a lot of things change in a matter of months. So just generally what we'd like to do in this unit is have a look at the fundamentals instead of looking at the specifics, because the specifics are going to change a lot. Although we do need to think about them and we do need to talk about them, but only in the service of trying to understand the fundamentals. And I want you guys to keep that in mind while we're going through this. So anyway, that's one example on one extreme. What about reality? Now, it's like, oh, but why are we talking about reality? That's not an immersive environment. Well, for our sake, for this particular unit, let's consider it as part of our remit. So one example of this would be a restaurant. And so in a restaurant, you design the ambiance, you choose the decor, you choose the menu, you hire the staff, it's basically pretty much the same thing that you would do in an environment over here, but it's just in real life. And then I guess here in between we have the augmented reality and mixed reality things. But yes, going back to this slide where I've listed all these different modalities of interaction, like along the continuum. This is by no means an exhaustive list, but you can see already, as I'm listing them off the top of my head, it's already quite a lot. We don't really want to be focusing on the specifics. We want to be having a look at the fundamentals. So let's step back a little bit. So in this class, what do we mean by immersive experiences? So let's define it, let's pin it down. So in this class, what we mean when we say immersive experience is here in an immersive environment, it's not just a screen. So we're not just going to consider what we play around with devices like this, or just devices like this. There needs to be something more. Perceptually all-encompassing, basically what I mean by that is it needs to be 3D basically. You'll find that a lot of the experiences that we have, it really is perceptually all-encompassing, from reality all the way to virtual reality. But I just want to make that distinction between screen-based interactions and immersive interactions. So it's quite a rough definition, but you'll mostly find that a lot of the things kind of fit. And hopefully you know what I mean. And if you don't, please send me an email and let's discuss that even more. In fact, you could even discuss that in the forum. And I invite you to post questions and discussion topics in there anytime you want. That would be really amazing. Anyway, second point, intuitive affordances, right? What do I mean by that? I basically mean that we don't need to go through documentation or read a manual to be able to interact with it. Let's say a typical program, let's say Microsoft Word, you need to know what the file menu options are, you need to know what all the different icons do and that kind of thing. Intuitive affordances, we don't necessarily need to look up a manual to be able to do what we need to do in that particular environment. You should just be able to walk up to someone and talk to them, for example, or if you're ordering food at a restaurant, you kind of already know how to do that. You don't need to read a manual. You talk to the server, the waitress, or the waiter. You point to the item in the menu, things like that. Or let's say you open a book, you have a pen, and you know how to write with a pen. Or if you have a light board, actually this light board was a little bit of a bit of an effort. I needed some technical help. Okay, to not labor the point, I mean generally not 2D. So the interactions in immersive environments would be, you'd typically be using your hands, you might be using your voice, you might be using the position of your body, you might be using your gaze, but essentially it's just not on your screen and click, click, click. Okay, I guess the final point about this that I'd like to make again is it's not really just about fancy headsets. Although certainly is a part of that, and that's one of the things I'm super excited about myself. But that's why we talk about the restaurants as an example. Okay, I guess the next fundamental point I'd like to make about our field is that it's highly interdisciplinary. Say that word 10 times fast. Interdisciplinary, interdisciplinary, interdisciplinary. I guess that's why people just say transdisciplinary, because it's a little bit quicker. Anyway, just think about what's needed to create an immersive experience. Even just in the case of the restaurant, you need to think about everything. But like let's think about like a game in virtual reality, for example. So what's needed for something like that to even come together and be an actual experience that someone can actually experience? So like you need application developers, you need hardware engineers, you need people to write experiences if it's a narrative experience. You need musicians, you need audio people. It's a convergence of all these different disciplines with their own specializations. I guess that's one of the things that I really love about this field. I get to meet people from everywhere. It's basically like it's a little bit like film actually, but the next evolution of film, because film is a little bit like that. You need like people who know about lighting, you need people who know about sound, you need people who know about lenses and electronics. So that's really cool. But one of the difficulties that we find in this field is we end up with a bit of clashing. There's a little joke in computer science where if you're stuck solving a problem, your colleagues would tell you, I guess you're just not Asperger's enough to solve this problem. And that's a joke, by the way, But I guess what I'm trying to say is because we come from all different places, we have different specializations, we end up with some culture clashes. And sometimes that manifests itself in jargon clashes. Like, for example, ever since meeting Teresa, for me, because I come from a computer science background, the word simulation I didn't know was actually quite loaded. So it means a lot of things to different people. Okay, so how would we deal with this clash of cultures, this different perspectives? And what I suggest to you guys is just be open and ask questions. Yeah, what do I mean by that exactly? Being open to me means that if I hear something that just rubs me the wrong way, like instinctively, I won't immediately dismiss it, but instead I'll ask questions. I'll be like, what do you really mean by that? And usually by sort of drilling down and asking those questions, you'll end up with something that kind of makes sense as the other person explains what they really mean. And then often you'll be like, oh, okay, that's just this other thing that I've already experienced, but I call it this other thing. Just think about that when you're dealing with these kinds of frictions. Okay, next slide. So, that's quite a lot of exemplar studies. But I'm just gonna go ahead and rub this out. I guess that's one advantage for doing recordings. You can like fast forward things that you don't really need to have a look at in real time. Okay, so let's list some important case studies. I know I said earlier that we shouldn't be concentrating on the specifics, but I've chosen these particular case studies because they're important somehow. And as we're going through these, I'd like you to think about what the user is experiencing, what the designer of whatever the experience is trying to achieve. And don't think about this as the very specifics, but let's just go ahead and list all these things, and let's cross them out as we speak, as we finish talking about them. All right, so let's redraw the continuum because I'd like to refer back to that from time to time, and let's make it really long. So. I really hope that gets picked up by the boom mic. And let's look at the cases that we want to have a look at. Ooh. Okay, so that's quite a lot, and I apologize for my handwriting. But if you can't read my handwriting, please refer back to the slides, and please tell me which particular ones you can't actually read so I can improve it. Anyway, yes, this is quite a lot. I know I said that we shouldn't be looking at the specific things, but it's useful to look at these specific things because there are things that we can talk about for them. As we're going through each one of these, I'd like you to think about what is the designer thinking about? What is the designer's goal for the specific user that they're thinking about? You can see that it spans the entire spectrum. So we have like restaurant and LARP, live action role playing. These would be very squarely over here. The Google Cardboard, this would be squarely over here. And then Cave System would be somewhere along this area. But anyway, let's just go through these one by one and think about what's important about them. So let's start with restaurants. I've already talked a little bit about restaurants, but let's just go through it again, just for completeness' sake. Okay, so what would a restaurant designer need to think about? And I'll say that I'm completely unqualified to do this. This is just me thinking about it from an immersive design point of view, and the knowledge that I have just comes from TV shows and also having just gone to thousands of restaurants in my lifetime, and the top one the top place frequented would be McDonald's, unfortunately. But if you look through McDonald's, they have quite a lot of user experience design in that area. So just everything from the uniforms that the staff wears to like the little ordering stations and the positioning of the barista, the positioning of the tables and the chairs. That all goes back to some kind of specific logic, and it's not a virtual reality game by any means, but it is an immersive experience. So just think about what sort of things need to be done in that particular situation. Now let's think about affordances. What can the user actually do in this particular situation in a restaurant? Well, they could pick up a plate and throw it at another user, grab a fork and then stab someone in the eye. They could pretty much do anything, because anything that's physically possible in our universe. But they're not going to do that because we live in such a thing as society, and you can actually call the cops for them to get arrested. But I guess the reason why I mention that is because we kind of already get a lot of things for free in the real world, if you know what I mean. So if you ever if you ever developed an app and then gave it for someone to test, it's a really harrowing experience. So right about now, I'm going to give you a link to a YouTube video. Maybe I'll actually just play it within this lecture. I'll edit it in, and you'll see what I mean.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square hole.
Yes. Okay.
And how about this rectangle? That one?
Also the square.
That goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin rectangle.
Can you guess where that goes?
The thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
the circle.
The square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
the semicircle?
Semicircle?
The semicircle.
That's right. It's the square hole. Okay. Up next, the triangle. We know what hole that goes into,
triangle.
Right?
Triangle.
That's right. The square hole. And up next, we have the arch.
The arch. The arch.
You guessed it.
The arch.
It goes in the square hole.
God.
And that was really excruciating to watch, wasn't it? So we do get a lot of things for free in real life, but we also need to think about the optimal user experience, or like the most productive user experience from our end as the designer, and also the most optimal user experience from the user's perspective as well. So let's move on to the next thing. So live action role playing. So I am a nerd. I'm very happy to admit that I own that identity. But the most I've gone in this direction is probably Dungeons and Dragons. I've never actually gone up and gone up to the forest and then promised everyone that I will be in character for the whole day. But this is essentially what live action role playing is. So what would a designer need to do to think about in this particular situation? Well, it's very similar to what someone writing a play would think about. They need to think about the costumes. They need to think about the different characters, the specific motivations. They'll need to tell all the different players how they should act. If it all works well, the whole group's going to have a great time. Let's cross out restaurant. So again, what can a user do in this particular situation? Well, it's real life. If you wanted your character to be able to throw an axe, you can just go ahead and throw an axe. I guess you'll need some modifications. Like, let's say you wanted to pretend that you were super strong. You can't actually use a real axe because you won't be able to throw it very far. So maybe you'll use a plastic axe that looks extra realistic. I don't know, but I guess the point here is, again, we're in real life, and we get a lot of things for free that we don't actually need to explicitly implement. So that's one of the things that I'd like you to think about if you're not from the software field, and you're trying to design software. You're not going to get all this real life stuff for free all the time. So the best you can hope for are tools, but if you wanted something really specific that comes from real life, very often you'll have to implement it yourself, unless you've got a lot of money and just pay someone to implement it. But yes. Now let's move on. Let's just wipe that off. Let's move on to cardboard. So it's something digital for a change. So cardboard is just right. So this is the Google Cardboard, and essentially what it is just a piece of cardboard with some lenses where you can put your phone in. Then tape it down, and the idea is you'd look at it through this way, and then you'd go ahead and look at virtual buttons, look at virtual things. You might have a 360 video playing, and many of you would have experienced 360 videos. Essentially, it's just a video recorded with a spherical camera, and the idea is you're able to look around as it's playing. It's a very rudimentary thing. So this is one of the so far one of the most common virtual reality experiences that that we have at the moment. Just another point about interdisciplinarity. This particular headset was built for the School of Built Environment, and as many of you will know, we are from the School of Art and Design. So you can just see how interdisciplinary our field is, because basically everyone needs to use us. Anyway, let's think about what the user can actually do in this particular modality. So Cardboard uses your phone. You can only look around in 3 degrees of freedom. What I mean by that is you can look this way, that's 1 degree, and then you can look that way, and then you can also look this way. So it's basically 3 degrees of freedom. You don't have any lateral motion. And in week 2, we'll find out that's actually quite important. But that's just basically a limitation of the technology. What can you do? What are the affordances available to the user? Well, not much really. In addition to having to design all the real world things that you would get for free, like being able to hold a pen, being able to throw things at people. We can pretty much only look around, have like a bit of an aiming reticle, like in the middle of our vision, and click on virtual objects. So that's pretty crap. So let's take a bit of a sanity check break. Why virtual? Real life has far richer affordances, right? But why even bother if all we get is this crappy Google Cardboard? Let's think about it a bit more. So in the case of the restaurant, how much does the decor cost? And like, who will actually install everything? You need to hire a carpenter and craftsmen and all that kind of thing. Again, in the case of the restaurant, you need to go ahead and recruit people, like the chefs, the waiters, the waitresses, the maitre d', and then in the case of LARPing, insurance is always a thing. What happens if someone has an accident while you're doing the role-playing session? Yeah, that's the motivation for us to use virtual systems, because it takes away a lot of that risk and a lot of that cost. So I guess that's just something to think about when we're designing these things. Now, having said that, we can still actually do a lot of things with virtual objects and virtual environments. So the rest of this lecture will now concentrate on things to do with virtual objects and virtual environments. And one of the very earliest systems that we had to display virtual immersive environments were these things called CAVE systems. CAVE stands for Cave Automatic Virtual Environment. This is one of those recursive acronyms like GNU, not Unix. So it doesn't really matter. It's just a nerd funny thing. So what would a cave system actually have? Well, to me, caves are characterized by super expensive screens that are massive, a bunch of tiny little tracking systems within that screen, and it usually takes up a whole room. We do have a few cave systems here on campus. Just off the top of my head, we have iCinema, and then we just over in Paddington campus, we've got Epicenter. I believe you can find links to these facilities on the Moodle page, so just have a look at that if you ever want to have a little bit of a visit. Unfortunately, I don't think we can actually do class tours at the moment, but I think they'll be accepting individual people coming in. But please do contact the facilities if you actually want to have a look. They're actually cool. They cost they cost a ton of money, well over $1 million for each facility, just because of the number of screens and the screen technology that they're using. Expensive projectors, super high refresh rate screens, and that kind of thing. Let's go back to the Lightboard and have a look at what the cave systems actually are like from the inside or from the outside. Anyway, let's look at cave systems a little bit deeper. So what am I thinking about? This particular cave system is from the mining school. And this is essentially a big room. So this is now the top-down view. And this is pretty much the layout of the room. This is the entrance. Over here is the corridor, and then they've got a bunch of cool toys inside shelves. This is the door into the facility, and then you have a bunch of control computers and screens and stuff like that here, and then you've got a little door that goes inside this particular room. So this circle here is essentially just a bunch of it's a bunch of screen. It's floor to ceiling, and then you'll have a bunch of projectors just behind the screen, projecting all around, and then you've got the user right in the middle. Let's make the user a different color. So the idea essentially here is to encompass the entire field of view of the user. It's floor to ceiling. There is a little bit of a caveat though, because there's a door here, and then there's also a door inside the live space, so like the screen space. And if you were to turn around as the user and look directly towards here, I think you'll see a blank screen. I don't think we've actually worked out how to close that particular gap. But this is how it achieves immersion, by doing it this way. So now, what's an extra thing that we can do? With cave systems, we have the option of actually tracking the user. Very often, like with this particular thing, if you don't have any tracking, you'll just get told to not move. Because if you can kind of imagine, actually, I wish I could just like move this particular figure that I drawn across, but like it's ink, so I'll need to rub it out. This is another limitation of real life. But if you were to just imagine that you're in this perspective, and the rendering was assuming that you're actually in this position, that you're not going to have the correct perspectives on the screen. So one way to combat that is if we were to just have a tracking device on top of you, and then you have a bunch of tracking cameras like in the entire environment. You're able to offset your position. The computers and the rendering will know. The rendering engine will know what your relative perspective is, and then it'll update the perspective on the screen depending on where you are. And that's a pretty useful thing to do. And we have that functionality in pretty much all our facilities here at UNSW. Now, what else can you do? Because you're in a real space, you can have props in there, and sometimes you can even have the props being tracked. So you can do things like draw in virtual reality. But that's just me pretending to draw in virtual reality, because this is actual reality. But if you can imagine someone drawing in 3D, that's actually possible. So what would happen is this person would be holding a wand or something like that, and that'll be tracked by the tracking systems. I think the black box over in Paddington campus has this capability as well. And I'll need to work out how to actually get that working. Yeah. Isn't it cool how isn't it cool how many toys we have here at uni? So now I'd like you to think about what can we actually do with this particular mode of interaction. Like these are all the different capabilities. What are the limitations of this particular mode of interaction? So I'd just like you to keep that in the back of your head. And in fact, I'd like you to think about. I'd like you to ask that question for all the things that we covered today. Okay, let's think about Pokemon Go. So this was popular, quote unquote, back in my day. It's improved quite a bit, actually. So I know I said I was a nerd before, but I'm ashamed to admit that I'm only level 21 in this particular game. And I leveled up quite a bit because a friend of mine needed to do an article about it for her research. And they were filming us around the place, playing the game, and I leveled up that way. But in doing so, I had a look at how the game actually evolved, which is pretty impressive. So in the past, Pokemon Go was essentially like a non-augmented reality game, a fake augmented reality game, in that all it really did was it took your camera feed, and then rendered some 3D Pokemon on top of that camera feed, but it didn't actually take into account their positions, their virtual positions in the real world. So what the new version does is something really interesting in that it actually tries to figure out what the topology of the real world is relative to the phone, and then instead of just arbitrarily putting the virtual object on top of the image of the camera feed, it actually tries to work out where it would show up on the camera image as if the virtual object was real. Let's say if a particular Pokemon was supposed to be walking around on a certain bed of grass, the phone will work out where that particular bed of grass actually is, and if you were to look at the behind the scenes or debug view, you'd be able to see the point cloud of what the phone is detecting, and then using this information, the phone would place the Pokemon in the correct location, or what seemingly correct location relative to the camera. So it's so when you move around, like laterally, up and down, you can see that the Pokemon stays in the same location on the ground. Yeah, this particular capability is enabled by something called SLAM, Simultaneous Localization and Mapping, and it does what it says. It's basically just saying it's mapping the local environment, and then it's using that particular mapping to localize itself relative to the environment. And so it knows where it is, so it can render the correct perspective. This idea of knowing your particular position, knowing your particular perspective is super important, as you saw in the cave system explanation. And this is just another way of doing the same thing. So, but the difference in this situation is, instead of the sensors and the trackers being stationary in the room, it's actually moving around. And then instead of the screen being stationary, the screen itself is moving around with the user. So that's what's another thing to think about? Well, in this particular thing, the way you would interact with the virtual world is through the touch screen. So you would be touching the ball on the touch screen and then flinging it to the Pokemon to try and catch it. Whereas with the cave system, if this were to be implemented, you would probably be using your hands. That's being tracked by the sensors inside the room. So yeah, again, just think about that. Like, why would the designers even bother with this? What was their goal? Why didn't they use a cave system where the user can actually have a closer experience to what throwing a Pokeball would be like, as opposed to just swiping a screen? Why did they do this? Why did they choose this particular mode of interaction? Next slide. Now, I admit this is a little bit of self-advertising, but it makes a point. This is kind of like Pokemon Go, but instead of the screen being in your hand, the screen is stuck just above Chatswood Library, and the screen is massive. Instead of the camera in the back of the screen looking out, the camera is just a shitty security cam with super low resolution that's running on Windows XP. Oh my god, that was an experience. If you're interested in me talking about like the getting past the technical difficulties of working with old software and getting it to work, I can get into that. But having said that, that was a local government initiative, and I was super scared that if we didn't get this done and implemented, we would all go to jail. But that's just a little joke there, not serious. But let's break this down. So what's happening here is still mixing the virtual world with the real world, but the perspective is fixed. And instead of the user having direct touch access to the screen itself, the way they interact with the virtual world is they move around. So you'll have a look at the video here. The little ball is sort of bouncing around the place, and then if someone were to get in the way of the ball, it'll bounce off that person, and it doesn't even have to be a person, it can be a bag. So the way I achieve that is basically just a very basic image recognition thing, object recognition algorithm, and what else? You could the cute bear will actually know the locations of the objects, and occasionally he'll walk around, but he'll always be looking at the closest object that it can detect. Yeah, so this is just like a stupid art installation for the Chatswood Biennale. Again, I'll ask that same question. What other situations would this kind of interaction be useful for, especially now with COVID? Like would something, this is a touchless interface, right? Would something like this be useful? So yeah, just something to keep in the back of your head to think about it. So let's cross this off. I kind of wrote this down in the wrong order. All right. If you feel like this is a bit of a fire hose of information, I guess you're just going to take a little bit of a break. But before you do, I hope that you can see the common elements across all these different modes of interaction. So there's mixing of reality and virtual objects, basically the virtual world and the real world, mostly. And then there's also perspective involved, which involves some kind of tracking. If you're completely new to this and it feels like a lot to absorb at once, that's okay. But those things that I mentioned will ground you. Basically, to be able to mix the real world with the virtual world, you need to be able to align those two worlds somehow. So it needs some kind of tracking, and it needs some kind of, for one, to be able to know the perspective of the user, and two, we also need to know kinds of things the user are doing to be able to interact with the virtual world, either if they're moving their hands or something. Okay, home stretch. Let's have a look at the HoloLens. So right about now, I would be giving you a picture of the HoloLens in the video. It's really cool how I have this light board in front of me because I can demonstrate somewhat how it works. And if you kind of just imagine that this, the glass in front of me, is the screen of the HoloLens. What actually is happening is it's right in front of your eyes. And the way it would display virtual objects for you, this is I don't know what that is. And this is like a 3D cat. And if you can kind of just imagine my perspective, I'm looking out into the studio, and into the studio, I can see this virtual cat being overlaid on top. Now this is special and different to the other ones, other modes of interaction we talked about, because there's actually no physical mediation between my eye and the real world, except maybe for the glass. So in the other interactions, we were using the camera, right? So what happens is the information from the real world goes in the camera first, and then it gets re-rendered onto a screen. Whereas with this, we have no screen in front of us. So that's something to think about. Now again, if you look at this device, this is a kind of Pokemon Go experience, and I don't mean that literally. It's just like, you know how when someone says, "Oh, just go ahead and Google it," they don't literally mean Google. Well, actually, maybe they do. But essentially, like what I'm trying to say is, Google has now become a byword for search. And I didn't really literally mean Pokemon Go. But I mean HoloLens is like Pokemon Go in the sense that it uses SLAM again. As the user moves around, the virtual object or the internal model within the simulation gets updated with a new perspective, so it aligns with what the user is looking at. The only difference here is instead of the perspective being controlled by a camera on a tablet or on a phone, like it's in someone's hand, like the screen's actually strapped to your face. Just think about also the key difference of actually being able to see out into the real world. How would this be useful? or how would this be not useful for particular designs? Yeah, I'd like to talk about these things during the live tutorial session, so I won't necessarily give you all the answers immediately, but I hope a lot of you are already thinking in your heads about the different possibilities that these different modes of interaction will have. So one of the things I will mention, though, is kind of like different to what we've talked about so far. The HoloLens can actually see what your hands are doing to such a high degree that it's able to simulate being able to touch virtual objects. So on your screen right now, there would be a video of someone using the HoloLens device to play a virtual piano. The way this is done is just by using the really powerful sensors on the device itself to be able to detect the orientation of your hand, the actual positions of your fingers and that kind of thing, and that's how it's able to align the virtual objects with the real objects, because it can actually detect the real object, which is your hand. Okay, home stretch, 3 more to go. Let's have a look at the Valve Index. Some of you might have heard of this. This is a gaming device. I know from previous cohorts in other courses that I've taught in this program that there's a bit of a yuck factor when it goes towards games. Valve is very much within the gaming industry, and I guess you'll just have to hold your nose a little bit, because there's a lot of important concepts from games that we can learn for immersive design in general. So I guess the reason why I put this the Valve Index in this particular position in the order of examining these different modes is all the previous modes of interaction that we talked about had one or another kind of problem. Let's compare the index to the cave system, for example. So the cave system is very, very expensive. You need like a space, massive space physically. You also need to pay for the screens in advance. Like the Valve Index just basically cheaps that out by making the screen really, really tiny and putting it in front of your face. I guess the HoloLens does that a little bit too. And but you'll find that all these different modes of interaction is imperfect in some way, and the reason why they've manifested themselves in this particular way is they've reached a kind of acceptable balance, so some kind of like an equilibrium where all the different trade-offs was actually enough to be able to achieve the goals of the design. You'll find that when you're designing immersive experiences, that you'll continually be having to think about this. The particular goal of something like the Valve Index is to be able to immerse someone with a very powerful computer already in a virtual reality game environment. So let's say something like Half-Life Alyx. So that means a lot of explosions and special effects and nice graphics, and then you'd want to be able to shoot guns and bullets, and you want all the tracking to be super accurate. You don't want to be cheated, like, let's say you supposedly dodged a gunshot properly, but the tracking system didn't track it properly, so you'd be like miffed at it if it didn't do the tracking properly. But you don't want it to be too expensive because you're just an enthusiast, you're actually not a professional. So but yeah, all these different things you can list out, but essentially that's why it uses the Lighthouse tracking system. It's basically an El Cheapo tracking system that just happens to have a high level of precision. If you really want to look into it, you can click that link, but it's in this case the exact technology isn't necessarily that important. The key thing for us is the kind of precision that it actually provides and its cost. So the same thing pretty much with hand interaction. So yes, HoloLens has hand interaction by detecting your hands using depth sensors, all sorts of nice image processing algorithms. but that increases the costs of the type of sensors that you have, and also like the onboard processing that's required on the device. So the index